Rotations are probably the most confusing of all of the transformations that we will be doing, and that is because you have to memorize these rules and apply them. It's not as easy as counting like we were doing with reflections or translations. So the rules, I've had them on the board in class, but the rule for a 90-degree, and it's always counterclockwise. This is how if they don't tell you otherwise, you are rotating counterclockwise. And so these are the rules that fit for that. So the rotation of 90 is to switch the x and y values, switch those places, and then change the new x value. So basically the old x value goes to the y and the old y value goes to the x, and it changes sign. So if b was originally negative, then now it would be positive. This negative sign does not mean that it's negative no matter what. It means that the sign changed. The rule for 180 is that a and b stay where they are, but they change sign. So you won't be having to switch the placement of x and y, just change all the signs. And then for the 270, they switch places, but the old x value, so the old a, moves to your y value and changes sign. The old y value is the new y value. So I had to memorize these just like you guys are. What I did was I memorized the 90 and 270 as a pair, and I memorized the 180 separately. I memorized that the 180 just changes all the signs. And then I memorized that the 90 and the 270, they both switch the x and y. And 90 is less than 270, so I thought to myself, well, in the 90, the first one changes sign, the new first one. And in the 270, it's the new second one. So that helped me that, 90 was lower and the first one changed signs, and then 270, the second one changed signs. So I always would memorize these, and I would always write the rule down when I'm doing the problem. That way I don't have to think about it over and over. So like here, they want us to do 180. So I might write to myself a note that I want to do negative a, negative b, to remind myself about what rule I was going to use. It says to rotate the figure the given number of degrees about the origin, list the coordinates of the vertices of the image. So we are going to list the coordinates. I'm trying to think, will these fit? These will not fit in this graph, so we're not actually going to graph them. We're just going to list the coordinates for this one. The old coordinates, we do need them, so I'm going to go through and I'm going to figure out what they are. A is currently negative 2, 0. B is currently negative 3, 2. C is at negative 2, 4. And D is at negative 1, 2. So you just identify where they are. Be sure that you have your points correctly written. That's a common error, to write them wrong. To have the x where the y goes and the y where the x goes, just like getting confused. It does happen. So for the new ones, so I'm just going to list those beside them here. The new ones, just all the signs change. That's all you're doing, changing every sign. 0 doesn't have a sign, so that will just stay like that. So the negative 2 became positive. The negative 3 here will become a positive 3, and the positive 2 will become a negative 2. For C, the negative 2 becomes positive, and the 4 changes to negative. And for D, the 1 becomes positive, and the 2 becomes negative. And so these are the points that you end up with, and so they're listed. On this next one, we're going to actually, we're given the coordinates. We are going to graph the polygon and its image. So know that this is going to require 2 figures in the graph grid. First the polygon, and second the image of it. So I'm going to zoom in a little bit because the graph, I want you to be able to see my graphing, and I have trouble seeing it myself. So here we go, a little bit bigger. A is at 1, negative 2. So here's A. B is at 4, 1. For negative 1. Oops. Good thing I have a key in front of me so I'm not making these mistakes. Here we go. 1, 2, 3, 4, -1. A lot of places for tiny errors, so always be careful. C is at 3, -4. There we go. So this is the original. And we want to rotate the original by 90 degrees. So 90 degrees, the rule is -BA. To remind myself of how that's going to rotate. So the new A value, I'm going to take this was B, it was A comma B, that's the original. So B was -2. Now I want -B in the front, meaning it's going to now be +2 in the front. And then A just moves to the Y place. So that's A prime. B prime, this was B, -1 used to be B. It's going to move to the front and change sign, and then this was A, it's going to move second. C prime, we had a -4 here, it's going to move to the front and change sign. The X is going to move to the back, and those are the new points, so we'll plot them. 1, 2, 1, this will be the new A. And then 1, 1, 2, 3, 4 is the new B. And then 1, 2, 3, 1, 2, 3, 4 is the new C. And then connecting those. So there's my new figure, and then a way to kind of check the rotation is to connect the origin, since we're rotating about the origin, with one of the old points and then its corresponding new point. And then you can notice that it's going counterclockwise, and you can see that this segment and this segment would be perpendicular. So because it's like a -2/1 slope, and this is a +1/2 slope. So you can tell for sure that those are 90 degrees to check that it's going 90 degrees counterclockwise if you want to check it. Then on the next page, it says to rotate ABCD 270 degrees about the origin. And then they gave us the coordinates. They want the polygon and the image again. So the original one, let's plot that. -1, -2 is where A is at. 2, 1 for B. 1, 2, 3, -1 for C. And then 1, -3 for D. So here's the original figure. And then we're going to apply the rule for getting the new coordinates. So A prime, well, it's 270, so the rule for 270 is B -A. So for A prime, it was -1, -2. So we're going to move B to the front, which is -2 in the front, and then A moves to the back and changes sign, so it was -1, so it'll now be 1. So that's the new A prime. For B prime, the 1 was B, moves to the front, the 2 moves to the back and changes sign. C prime, the -1 moves to the front, the 3 moves to the back and changes sign. And then D prime, the -3 moves to the front, the 1 moves to the back and changes signs, and these are the new points. And so we'll plot them, and that will be it. So A prime is at negative 2, 1. B prime is at 1, negative 2. C prime is at negative 1, negative 3. And then negative 3, negative 1 for D prime. And so we'll connect them. And then if you want to check and see, did it do a 270 rotation, you can check by choosing, again, a point to connect with the origin. I'm going to use A and A prime because to me they're the easiest to kind of spot. Connect them to the origin. And remember that when you do a rotation, you're going counterclockwise. So sort of around the left direction, meaning like this. And so you can tell that that's 270 degrees because over here would be 90. You can tell that those are 90 because those segments would be perpendicular, connecting to the origin and A and the origin to A prime. So you could double check it sort of by connecting that way. So those are our rotations.